In this lesson, we'll be talking about dictionaries with Python. Now, dictionaries are very similar to another data type that we have seen recently, which is a list. Both dictionaries and lists are collection data types in that they consist of a collection of elements. The difference is, whereas a list is an ordered data type, that means you can depend on some ordering for elements in a list, dictionaries are collections of unordered elements. Each element in a dictionary is a key value pair. Dictionaries are also referred to as a map data type or an associative collection. And that's because elements of a dictionary map keys to values. So let's see some code. Let's actually create a dictionary. So here is a couple of lines that create a dictionary and then print its content. So dict is our variable, and we have an equal to sign, and here you have an open and close curly brace. So obviously one key difference here is whereas lists use square brackets, dictionary use curly braces. Now in this case, this creates an empty dictionary. It has no elements. So let's add some elements. To add elements, you basically use the square bracket operator and you provide a key and you equate that to the value you want to map it to. So in this case, the key 1, the string 1, is mapped to the value uno. The key string 2 is mapped to due, and so on. Now if you were to print this dictionary or output it, it would look like this. Notice that each of the elements are of the form key : value. Right? And the other thing you'll notice is the use of commas between the elements. And this is very similar to lists. The key can be any object that is immutable, that cannot be changed. So a string is immutable, so you can use that as a key. The keys are also unique, so you can only have one element that has a particular key. The value, on the other hand, can be any Python object. Another way to create keys is to actually list the contents. So here I have a new variable, but I'm explicitly listing the elements of the dictionary. Now, the thing you'll notice here is this dictionary and the one I created before have identical elements, except they are listed in different order. The question is, does this make a difference? And no, it does not, because dictionaries do not have an ordering. It does not matter in what order they appear when you try to print them. We can see if these two are indeed the same by using the Python equality operator, which is equal to equal to. So if you do dict equal to new dict, it shows that yes, they are indeed the same, because this operator checks whether the two dictionaries have exactly the same elements. Another operator that we want to be aware of is the assignment operator and how it behaves when used with dictionaries. Note that the assignment operator will create an alias. It will not create a new copy of a dictionary. It will just create a pointer to the same location in memory. And this can be checked by using the is operator as we've done with lists. So let's take a look at example. Now here, if we checked dict is new dict, and since these are two different objects created in two different times and ways, this is indeed false. They are not pointing to the same location in memory. Now if we use the assignment operator, which, recall, it creates an alias, we create a new variable called myDict equal to dict. Here it creates an alias, and if you check that, and it does return true, that these two variables are pointing to the same location in memory. Now we can use the key to get the corresponding value in the dictionary. And to do this, we use the square bracket operator with the key being passed in. So here's an example where we get the value associated with the key 2, and it returns due. We're printing it so you don't see the quotes around it. If you were to actually just evaluate the variable, you would see the quotes. Right. Now, what happens if you try to access a key that doesn't yet exist in the dictionary? What will happen is you'll get a key error runtime exception. So in this case, if I said dict4, now 4 is a key that doesn't exist yet in the dictionary, it'll give you a key error for it. Right? You'll recall this looks very much like indexing into list, whereas there we used a number index and here we're using a key. Note that if a key already exists in the dictionary, an assignment will update that value. So let's look at examples of that. Here we have dict, where we have keys 1, 2, and 3, and they include the Italian number translation for those words. Now, suppose we change 2 to dos, which is the Spanish version of it, and 3 to tres, and then we print the dictionary. Notice that it hasn't created new elements, it has just updated those two elements. However, if we do use a new key, a key that doesn't exist yet in the dictionary, a new element will be created. So if we were to say dict4 is equal to quattro, then it will add a new element. Now here's some interesting corner cases. What happens if we explicitly create a dictionary by listing the elements, but the two elements are identical? Now, all the elements are supposed to have unique keys. So what happens there? And if you try to print it, you'll see that it only created one of the elements. It only put one of the elements in the dictionary. Another example is what if there are two elements here with the same key, but with different values. So now they're no longer unique. These are two different elements, except that the key is not unique. What happens there? If you try to print it, you'll see that it will insert the second one, or the last one it saw. Two interesting cases. We can use indexing into the dictionary anywhere we would normally use such things in expressions. So let's take a new example. Here I have a dictionary which represents an inventory, and it shows that apples has a certain quantity, pears has another quantity, and bread has a third quantity. If you print it, you see the dictionary as expected. Now suppose you update the value of pears to 0. Perhaps the pears have run out, right? And then you print it, you'll see the pears have been updated. Now you could use these indexing into dictionaries anywhere you would use index variables in expressions. It can appear on the left side, it can appear on an expression on the right hand side. Suppose you get a bunch of new pairs, 200 new pairs, you can update it such, and then you will see it reflected in the dictionary. We can use the del operator to delete an element from the dictionary, much like we could do with lists. So here I want to delete the element associated with bread. Perhaps we have stopped selling bread. We say del inventory and we index with the key bread. If we print it, you'll see that that particular element is gone. We can use the len function to count the number of elements in the dictionary. Here I add a couple of more elements for bananas and watermelon, print it, and it shows that it has 4 elements. Now there is a get function that we can use to avoid the key error runtime exception that we get if we're indexing into keys that don't exist. So here's me indexing with guava. Now guava doesn't exist in the dictionary, so I get the key error. But if I were to say get guava, it actually returns none. If you were to actually print it, that's what you will see. Another version of get allows you to pass in a second argument, which will be returned if no element with that key is found. So since guava is not found, it returns a 0. So a useful utility. We can use the in and not in operator to check for membership in the dictionary. So we can say guava in inventory, and since guava doesn't exist, it returns false. Pears in inventory will return true because pears does exist. Grapes not in inventory gives true because grapes indeed are not in the dictionary. We can iterate over the elements of a dictionary just like we did with lists. However, there is an important difference. Unlike lists, we cannot depend on an ordering that the elements will show up in the iterations. So let's take an example. I'm going to copy a piece of code and then we'll talk about it as I am running it. So here's a dictionary called inventory, the one we have seen before. It has 4 elements. To loop over them, we create a for loop as follows. We say for k, which represents the key in inventory. So k is the loop variable, and in each iteration, it'll be populated with a new key. Now, in this code, we want to print the keys and values of the dictionary. So we print k. And then we use k to index into the actual dictionary. So let's run this and see what it looks like. And as expected, it basically prints the key value pairs. All right. Now, suppose you were not too interested in the keys and you just wanted to loop over the values. You could do that too, and there'd be a subtle change. You would change this to v for values, and we will use the function values here. And now you will just iterate over the values and just print the values because you're not interested in the keys. So let's see what this looks like. If you were to do this, it just prints the values. So that is what I've shown here. 2 ways to loop over dictionaries. Now, let's talk a little bit about how dictionaries and lists work together. Recall that a value of the key value pair can be any Python object. So we can have a dictionary called scores, which maps a person to a list of scores they might be getting in a particular class. So this is Jane Doe and this is John Doe, and these are the scores they have been getting in their programming assignments, let's say. If you print that, you will see. So obviously you can use a list for values. Now, can you use a list for a key? And the answer is no, because lists are mutable. They can be changed, so they can't be used as key. So what happens if you try to do that? So let's actually take an example and see what happens. So here I have some count mapping that I maintain that certain characters appear a certain number of times. So here we're using a list for a key. And indeed, as expected, you get a type error. You'll get a kind of an obscure message, unhashable type list, which basically is pointing you the fact that this is not a immutable type as expected. So this has been a lesson on dictionaries.